Glad that many of you could make it to our special seminar this evening. This seminar is on artificial intelligence and the agri-food sector, and we're sending this seminar out to our students, our alumni, and also our OMAFRA partners. This came about because I was having some conversations with a former student of ours, Gary Chafe, and Gary is a master's in agronomy graduate, worked for a number of years for Climate Corporation, and then relatively recently was hired by IBM to be a senior digital agribusiness consultant. And Gary and I were talking about the world of artificial intelligence, and I was reflecting on the fact that I thought our students didn't have enough chance to, in their curriculum, learn about the fundamentals of artificial intelligence, and enough to get a sense of what the implications of this technology revolution will be for the agriculture and food sector in particular. And so Gary and I were talking about that and what we might do to help raise the knowledge level for our students, for our alumni, and OMAFRA as well. And Gary said, you know, IBM could possibly help with this. And I also want to say I'm very grateful to IBM for helping us with this seminar, for being the expertise in this seminar today. And Gary said, yeah, I'll reach out to people I work with and to see who might be available to speak on this topic. And much to my surprise, he came back with Dr. Seth Dobrin, and Seth is the Chief Artificial Intelligence Officer Global for IBM. And I said, wow, like that is way beyond expectations, but that would be fantastic. And so Gary, I'm going to pass it over to you to briefly introduce Seth. And then I have a series of questions to frame the topic, and Seth and I are going to have a conversation about artificial intelligence and implications for the agri-food sector. So Gary, over to you.
Certainly, thank you, Rennie, and hello, fellow Griffins and fellow Aggies. As Rennie mentioned, I'm a proud graduate from the University of Guelph as an Aggie a number of years ago. I will get out of the way quickly here. Just wanted to introduce Seth Dobrin, who, as Rennie mentioned, is IBM's first Chief AI Officer. Has done a lot of really impactful stuff throughout a number of industries that I'm sure he's going to kind of lay out for us here. As well as in impacting agriculture, he's also on a number of AI boards kind of in and throughout various industries. So I will step back. Just wanted to say thank you to everyone for attending. Please ask lots of questions. That's how we can have this be an engaging two-way dialogue, and we can all walk away from this having learned something new throughout AI and its implications in agriculture. So with that, Seth, take it away. Thank you so much, everyone, and enjoy.
And I know Seth's going to come in. I hope people can still hear me. I'm assuming that people can still hear me. I won't be on camera, but I'm going to be asking questions, and then Seth is going to be responding to those. And the first question, no surprise, is what is artificial intelligence? And just to frame a little bit, I mean, this is obviously a big question, but it's also very important and a fundamental question for this audience, for myself. So, you know, we'd like to understand in basic and fundamental ways what is artificial intelligence. So Seth, I will turn it over to you.
Yeah, I mean, so at its basis, artificial intelligence is really thinking about how we use math and computer science to help us solve problems better. And often I like to reframe it actually as augmented intelligence, because artificial intelligence should help us make better decisions. For the most part, it shouldn't be making decisions for us. I mean, there are some routine tasks that maybe we want to automate away, but for the most part, it's about providing better insight to us as humans to ultimately make the decision. When it comes down to it, we often think of artificial intelligence in a consumer way. So when we think about, you know, artificial intelligence, the first thing we think about is, you know, is Siri or Alexa or or one of those capabilities. But when we start looking at artificial intelligence in an industry context or even an academic context, it is actually fundamentally different, because there are consequences for the actions that are recommended by the artificial intelligence, or by the decisions that are ultimately made. And so we need to start separating AI in the context of our consumer lives and AI in the context of our business or academic lives. And so, for instance, if Alexa says, gives me a wrong answer to a question, really, who cares, right? So 3 tablespoons isn't really a quarter of a cup, right? But if Alexa is, say, I don't know, like in the UK, or if an AI, like it happened in the UK, is making a decision on what your grade should be in the middle of a pandemic because you couldn't quite complete it and it somewhat gets it wrong, or admissions decisions, that has impact on real people. And so I think we need to often separate those two things. When it comes down to execution of AI, we often conflate a couple of things. So when we talk about AI, it's really turned into a marketing term these days. It's probably made up of 4 or 5 discrete things. So first and foremost, it's things like neural networks, so deep learning, artificial neural networks. These are really advanced mathematical equations that have honestly been around for a very long time, but just now getting to a place where they could scale. That leads to natural language processing capabilities, that leads to vision recognition, and some other things. Then there's what we think of as machine learning, which neural nets and deep learning, and those are a type of machine learning, but there's more basic machine learning. And these are, using math and computer science to do things like logistic regression is a type of machine learning, and hopefully you all have taken that, or most of you have taken a stats class, you know what logistic regression is. When you use that as a continuously learning cycle, that's probably the simplest form of what we think about as machine learning. And then there's statistics, which is often lumped into AI, and traditional analytics. And then there's this whole suite of tools called decision optimization or operations research, which is where you mathematically simulate the real world or real world scenarios, and you alter them in order to identify what the best outcome is. And a lot of times we chain these different tools together to provide an outcome.
Well, that's great. That's a fantastic and succinct definition and explanation. I've been doing a little bit of reading, but I haven't come across, I have to say, I haven't come across such a clear and concise explanation. So I really appreciate that. And the practical examples. I mean, yes, I don't know if I really, I guess, once I think about it, Alexis is AI, but those practical examples are great to have us make it real for ourselves. What role, we hear a lot about data, and what role does data play in the development and functioning of AI? And to what extent is the phrase, data is the fuel that drives AI true?
Yeah, so I'll address that last point first. So once you use fuel, you consume it. The data is a commodity, just like fuel, just like corn, just like beef, just like any agri product, right? Since we're talking to an agricultural group. However, once you consume those commodities, it loses value. Data is fundamentally different as a commodity in that as you use data, it actually gains more value. And so I don't like the analogy that data is the fuel, because it's more it's more like you're getting more value every time you use it. So it's not a clean analogy to me. To your original question, though, I don't know a better analogy, so I can't replace that with something else other than a perpetual time machine, maybe. But your original question about what role essentially does data play in AI? When push comes to shove, I alluded to this earlier. What we talk about as AI is just mathematical equations, and mathematical equations are taught in this context. So these equations are taught based on data, and So data is actually paramount to the development of AI. In fact, you really can't develop AI without data. And so in some cases, you need very large quantities of data. So that's where the term big data comes from. In other cases, you need immense quantities of data, like the whole of the internet. So there are some AI models that have been trained literally on the whole of the internet. But that factors in something else. That factors in this concept of trust in AI, and things like bias, and things like context. And so, the math itself, so we often hear that, there's these bias outcomes in AI models. So there's been a lot of press around the Apple Card issue. There's, Wells Fargo, other entities that have used AI and got inadvertently bad outcomes. The math itself is not biased. The bias is learned from the data that it's being trained on. And in fact, the databases that those data are stored in are not biased, right? And the bias actually comes from past decisions of humans. And so I'm getting a little bit beyond your question here, but AI actually can do one of two things. It can perpetuate pre-existing biases, or if we address it properly, it can help us mitigate and prevent biases from being propagated moving forward. A great example of that is, let's go back to mortgages. So back pre-1980s, 1990s, there was this practice that realtors and mortgage brokers did called redlining. And essentially what they did is they drew red lines around parts of the country, and they said these people don't get mortgages because they're Black, because they're brown, because they're Jewish, because they're some underrepresented group. So we're not going to give them mortgages. Fast forward, to the early 2000s, there was a bank that was trying to address this problem of redlining, and they were trying to eliminate it from their processes of giving and underwriting mortgages. And so they said, we're going to do a pilot in New York City, and we're going to remove gender and race. Not even going to be in the data that we're going to feed into the model. Now, the way machine learning works is it picks up on little nuances, and it's actually really good at discriminating A versus B. And so it picks up on things that we may not want to see. So the people who are building this model removed race, they removed gender, they removed every other identifying factor they could think of that might link someone to being Black in this case. And lo and behold, they build this model, they implement this model, they think they've solved this problem, and it's still discriminating against Black people. Now, why is this? How is this even possible? Well, it just so happens that in a lot of parts of the world, and a lot of parts of the US, especially in New York, populations that look alike and are from similar backgrounds live together, right? And so there's all these communities in New York City. I'm Jewish. All the Jews grew up in either Brooklyn, the Bronx, or the Lower East Side. Black populations live in a certain zip code, and so even though they removed race, they picked up on zip code. And so this is a way that it was propagated. Now, there's mathematical ways to address that today, but ultimately the point is to reemphasize that data is critically important. Good data is really important, and understanding your data and understanding the bias and distributions of your data is even more important.
I don't think I was expecting that part of the answer, but I really appreciate it. And starting that out by saying there's an issue of what is the trust in AI. And when you say it like that, and then tell us those examples, it really does make you think about what the implications might be of that. And you gave those examples, and you used the phrase that now we can do these things, or this is possible, or and I wanted to ask why are we hearing so much about AI now? So what's changed relatively recently to create what seems to be a revolution of this technology?
Yeah, that's a really good question. So a lot of the algorithms we use today were actually developed in the 50s, and between now and the 50s. And in fact, 25 years ago when I was in graduate school, so my background's in human genetics. So I have a PhD in human molecular statistical genetics. So back in the 90s when I was getting my PhD, we were using the same models that, for the most part, that we use today to do on my research project. So part of my research project was something called support vector machines. That's an unsupervised machine learning technique if implemented in to be continuously retrained. However, my dissertation took over 3 months to run when it ran successfully. That same project could run in minutes today, or less than a minute. And so that gets to what's different today. There's significantly more compute power. So that's one thing. So with the advent of cloud, with the advent, the adoption of GPUs for actually processing algorithms, that's fundamentally changed. Quite honestly, the advent of the internet and the adoption of the internet. So I mentioned earlier, there's machine learning models that are trained on the whole of the internet. Having access to all of that data is incredibly powerful. And so, plus there's tools and technologies that have been developed. So, back to my dissertation, it was hundreds of CSV files that started in Excel, right? And today, that same amount of data would be stored in a single database that I would have running on IBM Cloud or Amazon or somewhere else, and I would have easy access to it without having to parse all these different files together in order to run my project, right? Because you just couldn't create a file big enough back then in any kind of commodity hardware system. And so, to sum it up, kind of briefly, compute power, cloud compute, cloud storage, the advent of GPUs, and the massive explosion of the amount of data that we all have access to.
Yeah, those elements make sense, and then when you pull them all together, they've all arrived, and then new things are possible. Something that you said in response to the last question really struck me, and that was about, unlike fuel, when it's used, data can gain value. That's I don't think I've ever heard that before, and so I think that's something for all of us to digest. That seems to be a really important fact within the AI revolution. And it relates to my next question, which is, why does there seem to be so much excitement about AI in the private sector? And is there big money to be made? I'm probably answering my own question. Is there big money to be made in AI technology development and or AI-driven business?
Yeah. So I absolutely there's money to be made and there's money to be saved. And so I think if you look at the opportunity for this whole class of things that I described as being AI in companies. So before I was at IBM, I was at Monsanto, which owned the Climate Corp, which is how Gary and I connected. And when I said I'm a geneticist by training. When I was hired into Monsanto, I was actually hired to build and industrialize their molecular breeding platform. So how do you use genetic markers to advance plant breeding? So my team and I developed an industrialized platform to do this. We had labs all around the world, and we had all this data. And my boss said to me, when I was hired, actually, wouldn't it be great if we didn't have to plant plants to know the phenotype, the plants that we wanted to advance in a breeding cycle? So imagine you're breeding corn, and I'm sure all of you are aware, or at least vaguely aware, of what an agricultural pipeline looks like. When you're, we'll just pick corn or any other crop. When you first start a breeding program, you've got thousands of entries, which means that you need to plant thousands of rows. And in fact, a company like Monsanto, every crop, there'd be 250,000 entries per crop in the first cycle, right? So, and breeders used to walk up and down fields and go, I want that one, that one, that one, and that one, right? And they'd advance those to the next round. We had a decade's worth of data from breeding pedigrees. And we also had several years worth of genetic data. And we were able to associate certain phenotypes that ended up in the final products with genetic markers. And so in Monsanto at the time, we had 22 different crops. So we had 250,000 entries in the first row, 22 different crops. There's only certain parts of the world that you can do multiple seasons a year of breeding. We couldn't make the pipeline any bigger if we want to, because there wasn't enough land for us to expand to. Even if we wanted to throw, hundreds of millions of dollars at it, there was no more land for us to buy that could support the cycles that we needed to turn. And so our goal was to remove that first step and essentially make our pipeline bigger by freeing up that first step. So, and we were able to do that. So after 5 years, we were able to do that. But what does that mean in terms of your other question? Why are companies so excited about this? That meant if you look at the value of the products that we were getting out of the back end, so the value of the soy, the corn inbreds, or the corn hybrids, the soy inbreds, the tomatoes, the cucumbers, etc. Because we were able to eliminate that first step, the pipeline got bigger. That generated about $4 billion with a B of new revenue, because we were able to increase the price of the products because they had more value to the customers, because they had more yield. So that's immensely impactful. $4 billion over an extended period of time, but still, that's a lot of money. So that's a way you can make money. That's literally net new revenue. Ways you can save money. So supply chains, supply chains in a typical, heavy equipment company, oil and gas, manufacturing, even agriculture, make up at least 70% of your, consume 70% of your revenue, right? Typically, minimum. Imagine saving, 1%. By using AI to optimize a process, you've now freed up, you've increased your bottom line, by 7%. So you've increased your margin by 7%. So these are the kinds of things that you can do with AI in terms of creating new value, in terms of saving money. Now let's go to the pandemic. When the pandemic started almost exactly 2 years ago now, we were, and our competitors, Microsoft, Google, Amazon, we were at the heart of an instance where, healthcare institutions were being inundated with questions. Medical institutions were being inundated with questions. There was literally multiple hours of wait times for people to get questions answered as basic as, does my kid have school tomorrow, right? Or is COVID going up in my area? And so AI actually stepped in, and like I said, we and our competitors worked with CVS, the different governments around the world to just build very simple AI capabilities to answer very basic questions, so that you and I could get these questions answered immediately if they were basic, and people who actually had critical questions could get in to talk to a hospital or their insurance company or the pharmacist. And so essentially we used AI to minimize the load on the humans that were actually doing the work, that these companies or entities couldn't even find enough people to satisfy the need if they wanted to. So AI stepped in and quickly helped address that problem. In a matter of less than a week or two, we had these things up and running for these entities.
Wow, that's a fantastic answer. I mean, and you covered so much ground, which I guess is part of the point of the applicability of the technology. I mean, it's applicable absolutely everywhere. But I love the example of what sounded to me like, the creation of a plant breeding metaverse. It's which is awesome, and I think that's such a great example for our audience to hear. And I'm hoping that there are a number of our students and hopefully some of our younger students listening in, and I think it's very notable that both you and Gary, your backgrounds are not in computer science or data science per se, but you have backgrounds in your case in genetics, and in Gary's case in agronomy, and yet here you are working on arguably the edge of the revolution of this technology, particularly in Gary's case in relation to agriculture and food. I find that very inspiring, and I hope our students find that inspiring as well. And it's great how you framed that question around money to be made and money to be saved. I think that really resonates with farmers as well. Both sides of that coin, as it were. I think you mentioned you rattled through them, but who are the big players in the AI world? And maybe are there unexpected big players in the AI world?
Yeah, I mean, so I think if you look at the main big players in the AI world, it's IBM, Amazon, Google, Microsoft, Facebook, Apple, Netflix. I'd say those are the biggest players that everyone knows. Now, if you look kind of deep in industries, there's other big players. And so, for instance, I mentioned operations, research, and decision optimization. The oil and gas industry has been using those tools for 30 years. So oil and gas is really big in the space of using mathematical optimization and mathematical simulations to make decisions. Literally decades they've been doing that. Agriculture, so I mentioned Monsanto. Right, Monsanto is held up as one of the premier instances of what we talk about as digital transformation, which essentially is how do you use data and AI to transform your business. And so I listed a couple of examples, but now they're owned by Bayer. But Bayer, by extension, is a leading AI company. ING Bank. ING Bank they used to be in the US, they're coming back a little bit, they're based in the Netherlands. They actually think of themselves as a tech company who happens to be in banking. They use AI extensively. Capital One is another example of a bank that is fundamentally basing their business on AI. And you can go on and on, right? Tesla, is Tesla a car company or are they an AI company, right? And so you could go through every industry and you could pick a company that is leading AI in that industry vertical, and in and of themselves are a tech company who happen to be focused on a certain sector of the economy.
That's amazing insight. Yeah, and I like the example of Tesla because that is a head scratcher. I mean, what is that company? I mean, that company is about many things. For some people, it's about an electric car, but for other people it's about battery technology or distributed energy possibilities, space,
self-driving cars, image recognition,
data collection,
decision making, right? Yeah. I mean, it's all of those things. So yeah.
So and I think you've already answered this question to an extent with some of the examples you've given, but in what sectors is AI most advanced and most used currently, and then how has AI already transformed those sectors?
Yeah, so I talked about agriculture, right? So agriculture is definitely, especially plant breeding. So Bayer, so Monsanto, Bayer, Pioneer, so DuPont, Syngenta. These are all companies that have fully embraced AI and the tools of AI to fundamentally change how they operate. So plant breeding programs used to be, literally breeders with some intelligence going out, licking their thumb and kind of whatever the wind blows. And getting to more practical business, plant breeders were rewarded, and even animal breeders in industrial settings are rewarded based on how many lines they advance into production. They haven't historically, until the last 10 years, been rewarded on what is the value of what they're bringing to their company, because every part of the company was so isolated that you couldn't even make that connection. And so the tools of data and AI enable companies like Monsanto, like Purdue, like like Cargill, enable to connect different parts of things and predict, okay, this line that this person's advancing, or this, this animal, is now, this new bull is now going to have these outcomes, and able to reward based on that. So I would say, maybe I'm biased, but agriculture is definitely leading the way. Oil and gas, they make, literally, when they drop a well, it costs them $1 billion. Every time they drop a well, it's $1 billion. You better bet they use AI to make decisions to optimize that $1 billion they're investing, because even to a company, like ExxonMobil or BP, and these are all, not Fortune 100 companies, they're Fortune 10 or 20 companies, right? Hundreds of billions of dollars of revenue. $1 billion is still a lot of money. And so, they use AI extensively. We already talked about automotive, right? All of these technologies that are in our cars, from, backup sensors telling us that there's someone behind, an object behind us, to, cars stopping when there's someone in front of us, telling you there's a deer in the street. That's all obviously AI. So automotive has pretty deep AI. Financial services has also been doing AI for a long time, in the form of fraud detection, anti-money laundering, and these are all things that are mandated by law, so they had no choice. So banks need to be able to identify when people are trying to launder money. That requires some level of sophistication. Fraud used to be very rules-based, meaning, if Rennie is, he's based in Guelph, all of a sudden at the same time he's making a charge at a gas station in Texas, it's probably not him, we're going to decline the transaction. Today, they wouldn't just use a rule. Maybe Rennie's son goes to school in Austin at UT, and he has his credit card, right? So, they know you have one, you're using the card electronically at home, your son's using it and I'm just making this up, obviously, your son's using it simultaneously, thousands of miles away in Austin. Well, we've seen this before. We know something's going on that's legitimate because no one's complained about these charges, so we know it's not fraud. That's a way oversimplified version, but you get the point. So financial services, mortgage decisions, and so there's tons. I could go on and on about the applications. And again, there's not one leading application or one leading industry. There are absolutely companies that lead in each industry, but every industry today is leveraging AI to some extent.
Yeah, it's I mean, those examples you give are fascinating. It makes us, it's a great topic because it does really make us think about, what's possible and what's next. It also makes me think of an additional question, which I hadn't written down here, but are there things, maybe things particular to the agriculture sector, that are holding AI development back, or the application of AI back in agriculture? Are there things that may be particular to the ag sector that may stall the advancement of the application of AI? And those may be things that are common to other sectors as well. I'm not sure.
Yeah. So I mean, obviously, I have a lot in ag specifically. I have a lot more understanding of what happens in the plant world, because that's where I worked in a plant breeding company for 10 years. But if you look at the ultimate customers of a plant breeding company, so farmers, one piece of information that's incredibly valuable is what is the result that the farmers are seeing in the field. And farmers typically are very, close to their vest, if you will, about not only the yield, unless they happen to know they're one of the highest in the county and they want to brag about it, but how they got there. What are the agronomic practices they did to get that yield? So just knowing that these seeds yielded this much is not enough information for us to really understand, is that the best seed? Maybe she has much better practices and much better understanding of her land than you do, right? So we need that information. And so people are not necessarily willing to share that information because to them, it's a competitive advantage. And so, which brings to the point about other industries, is we need to understand processes that lead to outcomes for us to build the best AI to be able to predict those outcomes. And so when people, even within companies, we find that people don't want to share information because information is power. And so not having complete information inhibits us from building and implementing the best AI. And so that's one aspect of it. The other aspect is adoption. I bet if you were to ask every CEOs of every Fortune 1000 company in the world, they say yes, my company is using AI, is built as an AI team and is building AI. But when push comes to shove, how many of those models are actually getting used in production? It's a very small fraction. And that's for a few reasons. So one is, back to my original point, humans don't necessarily trust the outcome of AI. And so we need to help them trust that the AI is in fact helping them make the best decision. Oftentimes, we don't think about the human when we're designing the AI. And it's really important for us to understand that ultimately a human is going to be impacted by this AI, and a human is going to be using this AI. They may or may not be the same person. So for instance, back to the mortgage example, the human that's using the AI is the mortgage underwriter. She is the one that's using AI to help her make better, fairer decisions. The person impacted by the AI is the person who's applying for the mortgage. And so we need to understand things from their perspective to help drive adoption, because that leads to fairer outcomes. It helps us understand how we need to explain that so a person understands that first the AI was involved. Here's how it came to the decision. Here's why it came to this decision. Maybe even here's what you could do differently to get this next time, right? To get an outcome you desired. And so really understanding nuances like that actually lead to broader adoption. And adoption is by far the biggest inhibitor for AI.
Yeah, that makes a lot of sense. And it's great to see you in this role. Selfishly, because you do understand agriculture, which I think is good news for the agriculture and food sector. The last question I'm going to ask, and then I'm going to switch to audience questions. So we had some audience questions submitted before the seminar, and there are some audience questions coming in now. But the last one I'm going to ask is, and you alluded to this in terms of the stories about possibilities of bias, for example. But what should we be worried about with AI?
Yeah, so that's a really, really good question. It's really pertinent and really, really timely. So I think as I said earlier in the conversation, right? The AI is not itself. We often talk about biased AI. What is driving AI is math. Math is not inherently biased. What is biased is the data that came from previous decisions of humans. So AI can, as I said earlier, AI can do one of two things. It can propagate pre-existing biases that are ingrained in the data if you're not careful, or it can help us create better, fair outcomes. And so we should be worried that people who are building these AIs are all people that look like me and you, Rennie. They're all white men. So we need to make sure there is an immense amount of diversity in these AIs that are impacting decisions that we make every day, that are made for us in some cases every day. Diversity is incredibly important because it helps you see different perspectives, it helps different thoughts, it helps overcome biases. We all have biases. We all have different types of biases based on the language we speak, where we grew up, what our socioeconomical status is, what our cognitive state is. And so we need people. So when I say diverse, I don't just mean black or brown or men or women. I mean different languages you speak, different ethnic backgrounds, different socioeconomic backgrounds, different countries of origin, right? I mean, cognitive functions, sexual preference or orientation, things like that. So all of these are important because they all provide different perspective. And so we should be scared of, just a bunch of white dudes driving decisions that are going to impact our lives. And to do that, we all need to encourage people to enter the sciences in general, because, as you notice that neither Gary or I have backgrounds in AI, but we're both in the field, right? So you can learn it. So it's just making sure people are getting into the sciences, because it's not a huge leap to get into this space from there.
That's a great rationale and reason for pushing equity, diversity, and inclusion, which we hear a lot about, but it doesn't always land. And for some people, this kind of very practical rationale might really land in terms of pushing EDI, in terms of the quality of what happens with artificial intelligence and the inclusion that is then possible.
Yeah, interestingly, or not surprisingly, when you think about it, companies that are in the top quartile for diversity outperform their competitors by 35%. There was a McKinsey study on that. So not only is it the right thing to do, it's just good business sense.
And it's a principle of nature.
Yeah,
it's a principle.
Right. Especially in agriculture, right? You have too much of an inbred. It's either not going to perform well, or something's going to happen that's going to cause it to fail because you don't have the diversity.
Yeah, less resilient. Yeah, absolutely. So we have a number of questions that have come in from audience members, and so they're a little bit eclectic, but they're all very interesting. So I'll start with the first. It says, I'm interested in finding out about organizations or groups that are trying to set boundaries and rules related to the development and use of AI and robotics in relationship to human safety, i.e. as machines for service versus controlling machines. And I wonder if you have any insights in that.
Yeah, so just in the space of AI in general, there are bodies that are implementing regulations actually for AI. In fact, Canada had one of the first AI regulations that was implemented. So hats off to you. The EU is proposing a pretty extensive regulation around AI. New York State or New York City has implemented a regulation around using AI for hiring. And they all these, and California and Illinois have regulations that are coming up. All of these regulations have one thing in common that's important, is that they are precision regulation, meaning they're not regulating AI as a thing, they're regulating outcomes. So if I am going to use AI to hire someone, it is going to be regulated. If I'm, basically, if an AI impacts your health, your wealth, or your livelihood, it's probably going to be regulated. Everything else is different states of depending on the impact. And so yes, there are bodies that are doing it. There's entities like National Institute of Standards, ISO, things like that are developing standards that the regulatory bodies will likely use and measures. And in the space of robotics, I'm not really sure about that. So I don't know if there's regulations around that. I know that that AI does help with robotic safety. So for instance, back to my Monsanto days, we had a very highly robotic lab. If you stuck your hand in there, the robot would hit it. It would know something was in its way. And it wasn't just a servo because, timeout, because it would literally stop because it wasn't the feel that it expected. Because if it runs into a piece of equipment, it would move back and try again. If it runs into something unexpected, that uses AI. So there are kind of robotics that provide guardrails, but I don't know that there's any regulations in the space of AI for robotics. I got to imagine there is, but I don't. It's not my field of expertise.
Yeah, I wonder if it's a really good point. Like you talked about regulatory bodies, and it makes me wonder if underwriters, et cetera, are starting to look at this sort of thing for robotics, for example. Next question is a little bit of a long question, but there's some context around it. The effect of COVID on meat processing plants highlighted the challenges for people working in these types of workplaces where people are working in close proximity. Their work carving meats into saleable products is highly complex human skill. Do you see a role for AI in this part of the food processing chain? Or is this something that is too complex for machines, even intelligent ones? And will this remain a human dominant process? And then as a note, the asker says, Robots are currently being used by some meat processors to process large carcasses into smaller items to be further broken down by skilled staff. So I don't know if you've run across anything in the meat processing industry. It's fairly specific, but it is an important question, and we know that it's a key area where labor is a real issue.
Yeah, so I haven't run into anything in the meat industry in particular, but I think there's some common themes there, right? So you have a raw bulk product, a side of beef, right? It's probably relatively easy to design an AI that could take an image of the side of beef, and know that to get these bulk parts, I need to do an automated cut here, I need to do a cut here, not going to dramatically affect the quality of the meat. When you get into these finer grain cuts, the higher value, maybe even just the higher value pieces of meat, right? You probably want a human involved, whether it's, guiding it or doing the cutting itself, just because it's higher value, and there's, a lot more, a highly skilled human is going to outperform a robot, at least for the time being, by a long shot. And there is, AI assisted, right? So for instance, I just had knee surgery. I just had a knee replacement, right? My knee was modeled in 3D. The doctor went in with a robot, and the robot probably could have done it its own, but he had his hand on there and he was guiding the robot to made sure it was doing the decisions he wanted. I'm very comfortable with that. I probably would not have been as comfortable with the AI doing my knee replacement without the doctor. So I think that's it's somewhat analogous in that very fine cut of meat he's making, right?
I think that's such an excellent answer. That is a great analogy, and you brought up AI assisted, which is also great for us to hear, and a reminder that it doesn't have to be the Jetsons from day one. Like there can be incremental in between technologies, and AI can be a part of those steps, those phases. That's really helpful insight, actually, and probably for the audience, can help to spark the imagination in that it doesn't have to be everything all at once, but in between.
Doesn't have to be everything ever necessarily.
That doesn't have to be everything ever. That's right. Absolutely. Yeah. The next question is about greenhouses. Greenhouse and controlled environment facilities, controlled environment agriculture, vertical farming, have integrated controls via software/hardware platforms produced by companies that we're familiar with, like Argus and Privia. How could we integrate AI into existing infrastructures like these, for example? So these are controls, but they're not really AI.
So I know in large scale glass houses and grow houses, there is already AI being used. So weather predictions for climate control. So for instance, instead of waiting until a glass house gets too hot to cool it off, the weather, what the weather is going to be. You would start opening windows, venting sooner, so you don't have to burn energy, right? Because not only does it create greenhouse gases to use energy to cool off a glass house, but it costs money, right? So again, back to the money thing. Even if for no other reason they're doing it for money, right? They're still also impacting the environment. So there is AI being used in temperature control. We use AI to predict, growing day units. So, how long we need we need things to grow to reach maturity. Disease predictions, in glass houses. So there's a whole lot of effort going in, especially in a greenhouse or a glass house environment. You get a disease in one plant, everything can be destroyed. And so being able to identify disease early through AI, through image recognition, things like that, that's incredibly valuable. That is being done today. And so I think there already is a lot of AI going on in this space, but there's room for more. I think especially as you get into kind of more vertical, maybe even hydroponic growing, what types of things can you learn from, what's the liquid that's being washed across the root structures? How do what are there things you can do? Can you optimize fertilizer, chemical input the chemical inputs that are going in there. Seed density, so AI is used for seed density in various environments. So it's already pretty extensively used in kind of controlled environments.
Yeah, that makes a lot of sense, and it just struck me when you talked about maturity prediction, and that makes a lot of sense too. I mean, increasingly, real-time data-driven maturity prediction is such an important step in the possibility of, for example, automated picking or automated harvesting. It's an absolutely vital step.
And that's actually another thing, is automated harvesting, right? So getting robotics, I forgot about that. Yeah, so using image recognition to know when a pepper is actually ripe, and then using AI to pick that pepper. That happened. Tomatoes, that I'm sure you all know, right? Most of the tomatoes in Europe are grown in glass houses, are grown in controlled environments. There's a lot of robotic planting, a lot of robotic picking that uses AI, that needs AI for it to work.
Yeah, absolutely. A question from a student came in just a few minutes ago, and the person says, as a student of traditional agronomy stats, example, for randomized complete block trials, where do we start in terms of learning how to use AI for agronomy? That's a good question.
Yeah, so I think I didn't mention this when I talked about diversity, but also another piece of diversity is there is no one person that builds an AI model. It's a team, and there's various types of people on a team, and they range from what we think of as data scientists, which are people who understand programming languages like Python or R, understand stats, machine learning, advanced mathematics, linear algebra, advanced calculus, things like that. There's data engineers, and these are people who kind of build data pipelines, engineer the data so that it's available for that. There's decision optimization experts. I already talked about what those people do. And then there's data visualization. Those are kind of data journalists, people that help tell stories in context and humanize, like I mentioned, the AI. And then in these teams, there's something called a product owner. And a product owner is a subject matter expert. And that subject matter expert is part of the team, and they bring that the knowledge, the depth of knowledge, of understanding of the domain to the table. And so that's one way, is just be an agronomist, but take part in a team. The other thing, and I encourage my kids to do this when they were in school, is everyone should take a programming language. So everyone should take a Python class or a Java class. Won't hurt you to take it. You learn something. At the very least, when you're interacting with people who are talking about stuff, you'll know what they're, you'll understand it a little better. And then, I never took a programming class. I learned how to program by myself. I learned about machine learning by myself from obviously a basis of stats, right? Because I'm a statistical geneticist. And so, as an agronomist, you have the basis to grow your skills, and that's something I actually I'm asked often when I talk to universities, and I try and do this a lot. What is the one thing you look for in a student? I look for the ability and the desire to continuously learn, because that's required. In today's world, you cannot, it's not like you're and my parents, where they got a job and they did the same thing for 50 years. The world is changing so fast that I've changed careers 3 times. I continuously learn all the time, and it's required that we all do that to stay relevant. And so, do it. Just start learning, apply what you know, bring it to the table, and have at it.
I love that advice. Keep that hunger for learning, and that'll serve you forever. and you need it to stay current, to stay relevant, to stay excited about what's going on around you. You need to at least have some understanding of what's going on around you, and that is fantastic advice. It recollects for me one of my PhD students in the past really enjoyed math, and there are parts of his thesis that are incomprehensible to me, even though I was his advisor, so to speak. I don't know. But it was an interesting thesis, and we did gain some additional insights because of his ability to model so well. But those are always an opportunity. I mean, he dragged me along, so it was an opportunity to learn. So that is really great advice for students, and learning a programming language, like you said, Python as one example. That's also good advice. And there are so many opportunities these days to do that that didn't even exist 5 years ago.
Yeah, I mean, the two most prominent languages in the field of AI are Python and R. And R was actually developed for the biological sciences. So it was a tool that was developed from a tool called S+, which was focused almost entirely on biological sciences, and so it was developed for people that don't know programming.
Yeah, that is good advice. Another audience member asks about going a little bit back to the questions about data and scale, and this audience member says, can collecting too much data hurt the acquisitions of insights? Can a data set be too big? There are companies in ag talking about collecting terabytes of data in fields. I worry that we won't learn anything from this because we might miss the small changes. So that's an interesting question.
Yeah. So I'm going to say there's no such thing as too much data. We need to. You can never. Once you throw away data, it's gone. And so you should collect it and have it there to be used. There are some legal reasons sometimes you wouldn't want it, but those aside, and the tools today that we have for building AI models, and I'm going to give two what may seem like conflicting answers, are very good at going through large quantities of data and surfacing insights, and so they are designed to go through these massive quantities of data. And terabytes of data is not as much as it seems like anymore. And so there's everyone should Google GPT-3. So GPT-3, I was talking about a model that was trained on the whole of the internet. So this is basically it ingested all of the internet to make things that do autocomplete. So there's lots of tools on the internet to do writing. So an AI that can write for you, put some things in there. Almost all of those today are built off of this tool called GPT-3. And so that technology would not be possible without large quantities of AI. However, there are instances where we don't have a lot of data, or we don't want to collect a lot of data. So for instance, we don't necessarily want to collect a lot of personal data about individuals, but we still want to be able to get insights from them. And so this concept that I mentioned about GPT-3, that's a model that's called a foundational model, meaning that it's trained on very, very large data sets. And now you can apply smaller data sets to those they're called large parameter language models in this case. You can apply very small data to train it for your slice of the world. And so for instance, if you wanted to train a language model that was specific to agriculture, you don't need a large corpus of data to train it from. You could start with this GPT-3 model. You could add the animal husbandry data that you have to it, very, very small data, and you could now train a language model that understands all the context, all the jargon, all of the nuances of animal husbandry without having to have terabytes and petabytes and zettabytes of data to train it from.
Well, yeah, when thinking of that question and listening to you answer it, that's a interesting answer about never too much data as a blanket. But it also strikes me that and we know, and you'll know this because you work in the agriculture sector, is that it's not about how much data we have sometimes, but it's about whether we can actually collect the data we really wanted to drive what we wanted to know or learn. And I always think of soils data, for example. I mean, it's so hard to collect some kinds of soil data like soil fertility because it's not easily automated. And so maybe as an add-on, I mean, What's your view been, or what have you seen around the use of proxy data, and I suspect AI probably has a lot of functionality in that respect as well.
Yeah, so there's a lot of things that you can interpolate from similar data. So you can create surrogates for some markers. They're typically not as robust and not as complete, obviously, but you can do it. We are getting into a world where you can actually do data generation. So you can actually simulate, create large data sets to train models. You need some context, some adjacent information. And so, but you can create these synthetic data sets, they're called, to answer some questions. I don't think we know quite how far that we'll be able to go yet, but it comes in very handy when you have instances of extreme security or sensitivity, like personal data or national security. It also comes in when we're looking at things like, talk about bias earlier. We're working on creating synthetic data sets that are biased. That way we can test to see if the model picks up the bias, right? And so if we run this data through the model, is it going to pick up the bias? So we're actually working on generating data sets to do specific things like that, but you could also theoretically use it to fill in gaps in the types of data that are collected.
Yeah, that makes sense as well. I think we wanted to wrap up not too far past the hour, and so I'm going to go to a final question, but it's a big question, and it's really about where we might be going with this, and actually one of the people signed up had sent this question ahead of time, and it mirrors one of the questions I had, but I'll use the audience member's question. And they say, what is your outlook on food security and the sustainability of our food systems when AI experiences an increase in adoption in agriculture? And to me, that was really a question about, what are some possibilities you see in the future around AI transforming the agriculture and food sector?
So when you think about food safety and food security, I guess food security is how it was phrased. There's a lot of different pieces in there. So for instance, there's the supply chain. 5 years ago, Qatar was essentially banished from the rest of the Gulf states. They didn't grow any food in Qatar. They imported most of it from Saudi Arabia, from other parts of the Middle East that all formed that blockade. They suddenly had a food shortage because they had a food insecurity issue because they were cut off from their food supply. So AI could help them, and did help them, optimize their food supply chain. So they were able to quickly replenish their food stores, and it didn't turn into a crisis, but AI did help that. So good example, I think, of food insecurity from a supply chain issue. We faced a little bit of that during COVID as well. So that's one aspect of it. The other aspect is disease. So food insecurity can come from, E. coli cropping up in lettuce. And because it cropped up in lettuce that went through this one factory, all of the lettuce that went through this factory had to get recalled and get destroyed. AI could actually help us determine where that originated from, understand what caused it, understand where it was introduced, and understand at what point, if you use your data and your AI correctly, at what point do you actually have to recall all the food? When was the last time the contaminated food was commingled with what is now in the store? So you no longer have to recall all the romaine lettuce for the next 6 months. That happened, 2 years ago, a year ago, right, in the US, where there was you couldn't find romaine for like 6 months because that happened. So so that's one aspect of food security. The other aspect of food security is climate change. And this has direct impact on food security, because that impacts everything from, you know, the growing days you have available for a given crop to the climate at a given latitude and longitude. So areas where you couldn't grow crops because it was too cold or wasn't warm enough or didn't have enough sunlight, now suddenly you can grow things there. Areas where you could historically grow crops like rice forever, you no longer can because they're now contaminated with salt water, right? So you have saline issues. And you know, there's a whole myriad of things that are being driven from climate change that affect negatively and positively our ability to produce food, our ability to have quality arable land to both grow crops on and graze livestock on. And AI can help us predict those things, the consequences and ramifications of them, again, good and bad, because it's not all going to be negative in terms of being able to produce food, but also how we address the issues. So how do we take advantage of the positives, and how do we address the negatives in a way that makes it more sustainable? And essentially gets back to what all the agribusiness companies really want to do, is they want to help feed the world on an ever shrinking amount of arable land with an ever growing population. And you're not going to be able to do that without AI.
I think that's a perfect place to end, to wrap up what has been a tremendous conversation. Seth, it's been an absolute pleasure being able to ask you these questions.
It's been my pleasure.
And to learn directly from you. You know, it strikes me that the history of agriculture is a history of adopting technology to advance the field, and here we are talking about the latest artificial intelligence and its absolute relevance to agriculture, and advances already being made, and the fact that you come from a background in genetics, worked in agriculture, and now are a global leader in a global leading big player in artificial intelligence, and it's absolutely an honor for us to be able to host you for the sake of our students and our alumni and OMAFRA listeners to gain these insights. So I really wanted to thank you.
Yeah, my pleasure. Maybe next time we can do it in person.
Yes, 100%. We would love to host you, and you know, I think there will be a next time, because this technology is in a revolution, and so there is lots to learn. I also wanted to thank Gary for facilitating this for us, Gary. I tremendously appreciate it, and you know, it's great that we started having a conversation in this vein that led to this possibility. I'd like to thank Aaron Levesque and Talia Dyer, who helped to set this up for us from my office in terms of the Teams platform. And I'd like to thank the audience members for questions that were sent ahead of time and for tuning in this evening. I know we've asked Dr. Dobrin and Gary if we can post this conversation, and I think we'll be setting that up on our website for people that want to tune in and watch at their leisure. What a tremendous learning opportunity, Seth, again, and I hope everyone has a good evening, and I hope, like you said, that we can see you in what do they say, in IRL, or in real life sometime. That would be great.
Yeah, thanks for having me. I really appreciate it, and happy to do this. It was a lot of fun.
Great. Have a good evening, everyone. See you.